Hello students, in this video we'll see examples of how recursively defined sequences can tend to a limit. So let's consider a sequence defined by a(n plus 1) is equal to 1 over 1 plus a(n) for n bigger than or equal to 1, and a1 will be set to be 2. So if we get a sense of what this sequence looks like, we can plug in and see that a2 will be 1 over 1 plus 2, which is 1/3. a3 will be 1 over 1 plus 1/3. That over there is going to be 4/3 in the denominator, so this is going to be 3 over 4. And a4 will be 1 over 1 plus 3 over 4. That's going to be 7 over 4, so this is going to be 4 over 7. And so on. We can keep plugging in more and more numbers to try to see what the limit is. However, if we assume, so suppose that an converges to a limit L. Well, if an converges to a limit L, this will imply that an plus 1, if the sequence shifted over by 1, will also converge to L, the same limit. So, with that in mind, we can take the limit of this recursion relationship, the limit as n goes to infinity of an plus 1 must be equal to the limit as n goes to infinity of 1 over 1 plus an. And if we're calling these limits over here L, so if we call this L and call this over here L, then what we see is that we'll have an equation that says L, this would be my L, is equal to 1 over 1 plus L. And now we have a quadratic equation in L to solve. And so this equation over here, by cross multiplying, will tell us that L times 1 plus L is equal to 1. These two things are equivalent to each other. And so therefore we'll have L squared plus L is equal to 1. And so then what we can do is we can rearrange this and write this as L squared plus L minus 1 equals 0. And then we can solve this equation and see that L is equal to negative 1 plus or minus the square root of 1 squared minus 4 times negative 1 all over 2. And that gives us two possible limits. It gives us negative 1 plus or minus the square root of 5 over 2. But we exclude, we know it cannot be negative 1 minus root 5 over 2 because this is a negative number. So we exclude this, and so we see what the limit has to be for this sequence is the limit must be negative 1 plus the square root of 5 over 2. So that's the limit of this recursively defined sequence. Let's see another example of this. If we look at an plus 1, which is the square root of 2 minus an, and we set a1 to be equal to 0, well, then we can plug in some values and see what we get. We'll get a2 would be the square root of 2 minus 0, so that would be square root of 2. And then a3 would be the square root of 2 minus the square root of 2. And we can keep doing this over and over and over again. We can do one more, actually, let's do one more. So a4 would be the square root of 2 minus the square root of 2 minus the square root of 2, and we get this nested family of square roots. But if we assume that the sequence converges to a limit, we would take the limit of both sides. If the limit as n goes to infinity of an is equal to L, then this relationship over here will tell us that L, because an plus 1 will also converge to L, is equal to the square root of 2 minus L, which I can square and get L squared is equal to 2 minus L. So L squared minus L minus 2 is 0, which we can factor as L minus 2. L, that should be a plus actually. So we'll have an L plus 2 and L minus 1 equals 0. Of course, L cannot be equal to negative 2 because we have a square root, so that's impossible. So we conclude that the limit of this sequence is equal to 1. So whenever I have a recursively defined sequence, I can pass to the limit and get an algebraic relationship for the limit L, and then we can solve the corresponding equation for L to find the limit of the sequence. Thank you very much.